Let's look at an application problem with the law of sines. Notice that it says two fire lookout stations are 13 miles apart, with station B directly east of station A. Both stations spot a fire. The bearing of the fire from station A is north 35 degrees east, and the bearing from station B is north 49 degrees west. How far to the nearest tenth of a mile is the fire from station B? So I would start off by drawing a picture to represent this situation. Notice that if they're telling us that the two fire stations are 13 miles apart, and it says that station B is directly east of A, well, that means that station B is to the right of station A. So I'm going to put station A here. Let's say that station B is over here. And I'm going to connect them because I know that they are 13 miles apart. They both spot a fire. Notice that with the bearings, both of the fires are north of where the stations are. So I'm just going to say, okay, the fire is right up here. Okay, so once again, when we're talking about bearings, remember, I want, like station A is north 35 degrees east. I want A to be thought of as then the origin when I'm thinking about my bearings. So hopefully it makes sense. Northeast is up and to the right. And so it makes sense that when I connect them like this, that is northeast. The fire is northeast of station A. Remember, when we're talking about bearings, the 35 degrees is always going to be formed with the y-axis or the north-south line. So that means that the 35-degree angle is right here. All right, and now we're talking about the bearing from station B to be north 49 degrees west. So once again, I want station B to be the origin of this bearing. Northwest means up and to the left, so that makes sense once again with my picture that the fire is up and to the left of B. And because 49 degrees is the bearing, that once again has to be formed with the north-south line, so that angle is outside of the triangle. So now we're trying to figure out to the nearest tenth of a mile is how far is the fire from station B. So my goal is to figure out what this length is right here. Notice that it's across from angle A, so I'm just going to call that side A. But we need a little bit more information because we only have one side in this triangle that I just drew. And so we need to recognize that, okay, 35 degrees is outside of the triangle. But remember, its complement is inside, because when we're thinking about that north, south, east, west, with those basically forming the X and Y axis, we're creating right angles throughout. So 35 degrees is there. Then 55 degrees is inside, because once again, they're complementary. They add up to 90. So then if 49 is on the outside over here, that means that 41 is going to be then inside right there, because they are complementary. Notice that with the 41-degree angle, I don't have the side that's opposite it. So while 41 degrees is an important number to have, I cannot actually use that in my setup. Now that I have 2 out of the 3 angles of a triangle, notice that 13 is across from the angle up here at the top. We can definitely figure out what that angle is because 3 angles of a triangle add up to 180. So to find that angle, I'm subtracting 55 and 41 away from 180, and that ends up being an 84-degree angle. Now we have everything that we need in our diagram to set up to find the distance the fire is away from station B. So I want to use the 13 miles, and that is going to go over the sine of now the angle that we just found to be 84 degrees. I want to figure out what the side of A is. Notice that that has to go over the sine of the angle that is directly across from it, which is the 55 degrees. Cross multiply, we have A being multiplied by the sine of 84 degrees. That equals 13 being multiplied by the sine of 55 degrees To get a by itself, I'm going to divide by the sine of 84. And then just carefully putting it into your calculator, thinking about order of operations. Once again, it's asking for the nearest tenth of a mile. And so the side A, which is representing the distance from station B to the fire, that is going to be 10.7 miles. And that would be my answer. So I think the biggest thing here is just, can you first and foremost sketch the picture correctly? Because once you have that picture, it's just doing what we've been doing now for these last couple of days, setting up an equation using the law of sines. So I actually have a checkpoint problem for you. I want you to pause this video and answer the following question. It says 2 fire lookout stations are 10 miles apart, with station B directly east of station A. Both stations spot a fire. The bearing of the fire from station A is north 25 degrees east, and the bearing from station B is north 56 degrees west. How far to the nearest tenth of a mile is the fire from station B? So once again, please pause this, try it, because in 5 seconds, I'm going to now show you the answer. All right, hopefully you were able to sketch this diagram correctly. Notice that once again, with the angles that they gave us, those ended up being outside of the triangle. I had to find the complements of those to get the 2 angles that were inside. And then I needed the angle up at the top, so I had to subtract 65 and 34 away from 180. And then I had everything that I needed in my triangle in order to then start solving for that distance.